Thanks everybody for being here. So yes, I will give you a presentation about spatial audio workstation. Two little warnings. First one, I'm sorry, but I'm the victim of a first demo effect and I'm running all this with a terrible screen resolution, but I hope it's going to be okay anyway. Second warning, as Jan said, it's a work that I've previously presented last year, and today I'm going to present the port of this tool on the Linux platform and also introduce a couple of new interesting features. And so, yes, I will start with a little bit of background to explain the context and the motivation of this work. And actually, the talk of Martin beforehand was already a quite good introduction, because you are all probably very well aware of the current audio and media production context, where on one hand we have seen in the last few years the emergence of 3D sound systems, for instance in a movie theater with Dolby Atmos and DTS systems and stuff like this. On the other hand, we have had in the very last few years a real boom or rebirth of binaural usage, especially for radio broadcast, with a strong interest from BBC, France Television, and other major broadcasters like this. Also, lately, a huge boom in the sense of 360 videos that are broadcast on YouTube and other platforms. Of course, everybody has heard a lot about VR and augmented reality experience in the last couple of years. Another important aspect is the use of high-density loudspeaker arrays, which are becoming more and more popular in concert venues or other installation venues. And also, as mentioned by Martin, a couple of web-based audio experiments, typically using binaural technologies. So that's a couple of things that are really... oops, sorry. Oh. Okay, so... How about that? Any better? Yes. Okay. So yeah, basically that's the current context where we see that a lot of people from a lot of different industries or fields are really interested in doing some spatial sound and creating some spatial audio context. So the question is how to do it. And to do that, I will just give a few hints about what are the production workflows, how a content producer do work. Basically, there are three main ways to create and produce spatial sound. One workflow is, let's say, traditional one, which is creating what we call channel-based spatial audio. So typically, the content producer will create a mix or a master tape that is dedicated to a given standardized reproduction layout, so typically a stereo layout or a 5.1 system, where the sound engineers knows from the beginning what's going to be the loudspeaker layout. It will produce the master tape, and on the end user will just have to play back this sound file according to its system. Another production workflow is what we call the scene-based production way, which typically refers to the ambisonic framework, where unlike the previous one, the sound scene is treated as a whole, as a global 3D sound scene, which is encoded. This encoded scene is transmitted over network or whatever media format, and it needs some decoding in the endpoint so that the decoder will adapt the content to the actual reproduction layout in the final room. Another production workflow is what we call the object-based, which refers to what Martin demonstrated, where we basically encode sound objects carrying on both the audio data and the metadata that are associated to it. So typically, metadata that refers to the location of the sound object in the space, in the virtual scene. And all this data plus metadata is transmitted up to the end user, and it requires some rendering on the end user side. So that's the three main approaches to create some spatial sound. And of course, in many situations, the content producer will actually use some hybrid techniques, combining one, two, or the three of the previous ones. Now, to try to make things a little bit more clear, I will talk a little bit about a case study because the context is way too big. I cannot talk about everything, so I will narrow down the scope a little bit, focusing about one aspect that we are especially interested in at IRCAM is how to deal with a concert with mixed music production, so typically acoustical instruments on stage that are augmented by electronic sounds. And where we are dealing with this kind of electronic music, we need spatial audio at different levels. First of all, we need it for the live diffusion during the concert. So that's one aspect, one question. How do we deal with the real-time diffusion of sound during the performance? Also, most often, or hopefully, a concert is given in several venues, and most of the time the diffusion system is different in each venue. So the question is how to be able to adapt one concert to different venues with, of course, trying to do that as fast as possible and with less effort as possible. So that's one aspect, that's concert time. And after the concert, there is also the question about how could we record, mix, and post-produce this concert to keep a track of these live activities and make it available to as many people as possible. So typically, how could we create a mix of a concert that has been recorded and maybe broadcast this mix over stereo, binaural, 5.1, ambisonic, or being able to address as many media as possible. To exemplify a little bit this, I will just take the example of one masterpiece of sound spatialization that was mentioned this morning by Thierry, which is a piece Répond by Pierre Boulez. This is quite a paradigmatic example for sound spatialization because this piece, maybe I have a picture, yes. In this piece is for orchestra, 6 soloists plus live electronics. And in the composition, Boulez decided to put the orchestra in the middle of the room, the audience sitting all around the orchestra, and we have the 6 soloists that are dispatched all over the room, so surrounding and overlooking the audience. And each soloist is augmented by some electronic sounds that is played and specialized over space. So we can see that a very rich case study for spatial audio. And again, we have this question about how to deal with live spatialization for the concert, and how can we record such a piece and make it available to the public. So for the recording, this is those are some pictures of the last recordings that we made. It was a few months ago for a performance in Germany. And in order to be able to capture such rich spatial scene, we have used quite elaborated microphone systems. So first of all, we have, that's quite traditional, a main microphone system that was hanging on top of the orchestra, and which is actually made of a, let's say, a 6.0 microphone tree. So it's pretty much a standard 5.1 miking tree, except that we have added an extra 6th microphone in the back in order to be able to capture the sound in the whole 360 horizon. In addition to that, we have also added an eigenmic microphone, which is an ambisonic microphone. So it's a small spherical microphone array, which is made of 32 mics on the surface of a sphere, and which allows to capture the whole 3D atmosphere of the piece, and later encode it into the ambisonic domain. So that's the main microphone aspect. Of course, this main microphone aspect is only able to capture the overall ambience of the concert, but we need some additional spot microphone close to the performer in order to capture them more precisely, so to say. So we had, that's also very traditional, a number of spot microphones close to the orchestra. And so that's the same picture. And similarly, for each of the 6 soloists, a number of spot microphones close to their stand. Okay, so basically we have been able to record all these things. And now the question is, how are we gonna work with this material, and what do we need? So we need tools to help us to mix, spatialize, maybe reverberate these very heterogeneous input materials. We want to be able to deal with hybrid techniques, hybrid paradigms, so either channel-based, scene-based, object-based, and probably combine all of them, because I forgot to say, but each of these approach has some pros and cons. There is no obvious winner, so we need to combine all of them if we want to take full advantage of their possibilities. And we want to be able to, as I already said, deliver some output material with being as flexible as possible. More technically, we need to be able to deal with a large number of tracks. We need to be able to deal with tracks which have some high channel count. So, for instance, if we think about the eigenmic, we need to be able to cope with this 32-channel thing. We need some tools that are as flexible as possible in terms of routing, busing, I/O, and everything, and which allows some sensible configuration. So let's have a look at what already exists, and what are the tools that sound engineers are using nowadays. So, of course, they are using a mixing desk, they are using a digital audio workstation, and they are also using a real-time environment like Pure Data or MaxMSP or stuff like this. Again, each of these tools have some advantages and drawbacks. So if we think about the mixing desk, of course, that's some very powerful tools. Every sound engineer in the world masters these kind of tools and know how to use it. However, these kind of devices are essentially tied to 2D surround production, typically targeting 5.1 or 7.1 channels. And they are not really able to deal with 3D sound spatialization. Typically, it's not possible to do any kind of binaural or ambisonic rendering in this device. On the other hand, we have a digital audio workstation, which are extremely powerful, very widely used. You have millions of plugins available. But they have some drawbacks. These drawbacks are mainly for, let's say, commercial digital audio workstation and do not really apply to Ardour. However, not everybody used Ardour for the moment, so I'm just mentioning the drawback of other systems. Other systems are typically tied to channel-based approach, with some very strong constraint on the number of channels that they can deal. So typically Pro Tools or stuff like this, you cannot do anything if you want to deal with more than 8 channels strips. And they also usually comes with a limited input and output. And all this makes the use of a sound spatialization plugin especially difficult, if not impossible, in this kind of environment. Again, this do not really apply to Ardour, which is a million more flexible than other workstations. Now, another set of tools that people are using, as I said, is real-time environment. Real-time environments are completely flexible. You can just patch whatever you want as you want, so and do all your routing and everything is totally flexible. They are quite flexible also in terms of number of channels that you can deal with. Typically in MaxMSP you can go up to 250 channels, which is not that bad. And there are, of course, millions, no, not millions, but many libraries dedicated to spatial audio and many very powerful tools that people can use. However, there are a number of things that you cannot do in those kind of environments just because they are not meant for this. Typically, you have no timeline. It's very difficult or tedious to deal with automation, grouping of things. And it's also a pain to have, let's say, a dynamic behavior, like, oh, I need to add a new track. I need to insert a new object. Every time you need to edit your patch and redo a lot of things, which makes the workflow a bit cumbersome and not fast enough in production context. So all this, this is a panorama of existing tools. And we came to the conclusion that none of it was really fitting our needs, so we decided to develop a new workstation which would try to overcome these limitations. So, yes, I will try to do a little demo. And that's my second demo effect, because I had prepared a couple of demos that were working super well on my PC yesterday, and today in the train I just found out that most of it was not working on this laptop. So I won't be able to play what I wanted to play, but anyway, I will improvise something else. Hopefully it will still make sense. So the workstation that I've developed operates as a standalone application to process audio, and it is compatible with Jack. So first of all, I will need to start a Jack server. Then the workstation is essentially as a plugin, but that you do not plug in, you plug it out. And so in typical use case, you need a workstation. So I'm going to use Ardour in this example. And I've prepared a very simple, simplistic session with 3 mono tracks. In this case, 2 guitar and a voice. That's pretty random, but it's just for the sake of demos. Okay. Now, so I'm starting the workstation, which is called Panoramics. That's just a name. And okay, so okay, at least you can see a little bit of it. Well, not too bad. I don't know if it's really readable, but at least you would be able to follow what I'm doing. So as you can see, it looks like a traditional workstation, and where we will have typically some input tracks that would receive the input materials, and where we will create a couple of buses where we will deal with the spatialization processing that we want to do, and in the end we will receive or deliver the processed signal ready for live diffusion or bounce to disk. Of course, I need to do a couple of audio connections. So I will connect the output of Ardour towards the input of our processor. And then I will connect the output of the processor to the, in this case, this stereo loudspeaker system. Okay. Then I can I will create 3 input mono tracks, as you can see here. I can give a name to this mono track just to match the session that is in Ardour. So 2 guitar and vocals. Just for the sake of clarity, we can just put some colors to the things. Okay. I will put 1 guitar here, 1 guitar here, and the vocal in the middle. Okay. Now, if I hit play in Ardour, okay, so Ardour is sending some audio signal, but nothing is coming in here for the moment, because first of all, I need to specify what is the input routing of the processor. So then it changes to choose. Wow. If the mouse disappears, it's going to be really difficult. Wow, 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 wow. Huh. Third demo effect. I'm sorry? I'm really sorry about that. Shit. That's a nightmare. Maybe I will try to unplug this. Yes. Okay, so the mouse is back. Sort of. Nope.
Maybe if you if you put a tweak on there, you can change the type of mouse cursor.
I'm sorry?
You can change the type of mouse cursor, maybe that brings it back.
Mouse. Whenever I plug the screen in. I think I'll try for a very quick reboot or logout at least, if that's possible. So in the meanwhile, maybe I can try to give you some details about the philosophy or the architecture of the tool. So basically, the idea is that this tool is able to receive various kind of input material, typically the stuff that I've mentioned beforehand. So either some mono signal, like could be coming from the spot microphones, or could be some electronic tracks or any kind of sounds that needs to be specialized. It could also accommodate on the input some ambisonic microphone, like the Eigenmic or first order. Yes, it's back. Yes, thanks. Amazing. What a success. So maybe just to try to save a few seconds, I will actually load a session that I had already prepared for this. So again, with these 3 input tracks, I have to redo this mess. Okay, and now, oh yes, I remember. I was talking to you about the need to do some input routing, where we would route the incoming signals, so coming from jack, towards the input tracks. So in this case, it's pretty trivial because it's just direct routing. Okay, now, supposedly, if I hit play and put this in the front. Okay, so now we have some sound coming in. Then what I need to do is to create one or multiple buses for sound spatialization. So we can create some buses, and maybe you can read that various sound spatialization techniques are supported, so typically VBAP, ambisonic, binaural, or some more traditional stereo panning techniques. In this case, I had already prepared a stereo panning bus, which comes along with a reverberation bus. Each spatialization bus is always attached with a reverberation bus that will generate some artificial reverberation, and they are tied together. I will explain a bit later. And then each track can be sent to one or multiple buses. You probably cannot read here, but in this case, I'm sending each of these 3 tracks towards this stereo bus. So here we can see on the input of the bus the signal coming from the track. And in the end, all this is sent towards the master, that is towards the loudspeaker. Where is the... False stimulus effect.
Well, the mouse doesn't.
How many controls are there before planning on each of the I mean, I can see like 3, but I can't read labels on each of the scripts.
Okay, so we have a number of controls. So on one hand, we have some controls over the location in space, of course. So we have a number of either buttons to control the location in space, like a pan as well as distance. As you have maybe noticed here in the bottom right corner, there is also a geometrical view of the overall scene, which of course you can manipulate the entities here as well. If you have multiple screens or a big screen, maybe it would be easier to outsource this stuff elsewhere on the second screen. So that's for the location. Then we have a couple of traditional parameters like EQ. So EQ with standard settings that you can adjust, okay, as well as compressors and expander for dealing with the dynamic adjustment of these signals. And then a couple of parameters that will deal with how the sound is reverberated. So we have some parameters to adjust the levels of the direct sound, early reflection, and reverb send to what is sent to the late reverb. All this is essentially built on top of the SPAT reverberation engine, which, yes, okay, since we have this question, maybe I can try to illustrate this. Okay, so that's the flow chart of the audio architecture. So here we have our track. Here on the top right corner, we have a representation of how the room effect is generated in both the time domain and spatial domain. So first, as you have noticed, we have some view meter to monitor what is coming into the track. Then we have a trim button to adjust the incoming level of this track. Then, as I've mentioned, we have EQ and compressors. Okay, possibility to change the phase of the signal. Then some filters that would simulate the absorption of the sound with respect to the air. Okay. Possibilities to enable or disable the simulation of Doppler effect for moving sound sources. Possibility to adjust the delay, typically in the sound recordings that we have made, maybe the different microphones were recorded with different delays, so we first need to adjust all the input tracks so they are in sync. And then we have really the reverb part that comes into play. So we have the possibility to adjust the direct sound, and as you have understood, the direction will be coming from a given direction that you have set. So it's going to be panned in this direction. Then it will generate a set of early reflection that are coming from various directions into space. So that's what's in there. Generation of early reflection and adjusting their gain and optionally filtering them. And so then everything is panned into space, and you can adjust the widths, perceptual widths of the rendered sources. And then all this early plus direct reflection is sent to the bus. And we have also one button to adjust the send towards the late reverberation bus. Now, what happens on the bus? So here on the left side, we have the spatialization bus, and on the right side, we have the late reverb bus. So again, we have some view meter on the input to be sure that the signal is where we expect it to be. Trim, again, EQ and compressors. Then here, you will find some controls that are specific to the panning algorithm that you have chosen. So if you have chosen stereo, there is not much control over it. But if you have chosen, let's say, binaural, you can make, in this strip, you will be able to select your desired HRTF. If you have selected ambisonic, you will find a couple of parameters to tweak the ambisonic rendering. Okay, and here on the right side, we will generate some late reflections and late reverbs that are spatially diffused, so coming from any direction in space, as it occurs in most real rooms. And finally, we have some view meter on the output, fader to adjust the gain, and everything is summed up and sent towards the master track. So does this respond to your question? Yes. I would like to have some sounds. So this works.
Where's the master bus going from the program?
Going there.
To system playback. Maybe the playback is muted. No mixer or something. Oh no, it goes /X. There's no way you can check that, I think. Jack meter, maybe? Yeah, in the end it goes to ASA, so we should be able to monitor to ASA mixer. Maybe it's muted. Okay, it's the wrong. It's only HDMI. Should I give you an extra audio device?
Check which device you're using in Jack.
No, that's the right one.
Yes, it looks good.
Okay, I'm so sorry about that, but trust me, you should be able to have some sound coming out. And anyway, as we are running a little bit out of time, I will just conclude to say that besides these technical live demos issues, that's supposed to be a pretty flexible tool that allows to deal with very various scenarios, channel-based, scene-based, and object-based. There are a lot of things that I still would like to implement and insert into this workstation. One thing could be to have the possibility to directly insert some audio plugins in this workstation. Again, on Linux and working with Ardour, that's not really a problem because people are able to insert their plugin already in Ardour and it works nice. On other platforms with a strong channel constraint, it would be nice to have the possibilities to deal with plugins with high channel counts directly into Panoramics, as it's too complicated to do that in Pro Tools or other software. Another missing feature is to deal with automatic latency compensation. Essentially, the software doesn't have latency except in very few spots, like typically in the compressor if you are using a look ahead or something like that. So I would need to implement some automatic latency compensation. Another thing that I would like to do is to integrate or support some newly developed object-based format, just like the ADM, which is an audio definition model, and which basically it's a new standardized standard format that allows to encapsulate into a WAV file some additional metadata, typically position metadata for sound spatialization. So it allows you to produce one single WAV file which contains pretty much all the information useful for this kind of work and sessions. Another extension that I'm working on is to integrate the use of a convolution reverberation engine. So at the moment, all the reverberation that is done in this workstation is using algorithmic-based reverberation based on the SPAT engine. But I also would like to be able to cope with convolution impulse response, or maybe hybrid reverberation engine, mixing both convolution and algorithmic reverb. And well, that's about it. I'm saving some time for questions. Yeah. I'm really embarrassed about all this issues.
For you, is that you have the demo effect. You will be free of demo effect for the next 10 years, at least. So you have time for a few questions?
Just short question. Just a quick one. When will we be able to run this as a LV2 or VST plugin in Ardour?
I don't have plans for this. I mean, technically that would be possible, of course. But in any other situation, we are using it as a remote external application. So I don't know if that's really useful or needed to have it as a plugin only for Ardour. Maybe that could be useful, but
Free software?
It's free, yes.
Is it open source?
No.
Then we don't call it free.
Only as a beta.
Not at the moment, for at least.
Okay, that was my first question. So it's not open source.
No.
Second question, is this just an interface to SPAT and Max, or does this do actual the processing?
I mean, it does all the audio rendering, as you have guessed. And yes, it's essentially a new user interface on front of SPAT.
It uses a DSP code from SPAT.
Yes.
Which is why it is not open source.
Which, I'm sorry?
Which is why it is not open source, probably.
Yes.
Okay, so it's time for the break. And if you have more questions, or maybe if you want to have a demo during the break, it's probably possible.
You can run it on your own laptop, and it's going to be fine, I'm sure.
So we will start at 4:30 sharp. Okay, so break.